Hi guys, welcome to Chibuzor Math Physics. I will be taking you through proving trigonometric identities. Trigonometric identities is commonly used in calculus, in analysis, in analytical geometry, in trying to find the derivative of a function, and even in finding the value of a certain equation to prove that the identity is true or false. So I will be taking you through on how to prove these trigonometric identities, and I hope you will enjoy it. My name is Augustine. Let us jump into it. First of all, what is proving identities? Basically, proving a trigonometric identities refer to showing that the identity is always true. No matter what value of x or theta is involved, the identity is always true. You can even use y or z, no matter what value you use, but we are trying to prove that this identity is true because it has to hold true for all the values of x or even all the values of y. We cannot simply substitute in a few values of x to show that they are equal. It is possible that both sides are equal at several values. That is when we solve the equation and we might forcefully think that we have a true identity. But sometimes we can solve the equation and then you think that you have a true identity, but it is false. So we are going to prove those identities and make sure that the identity is always true. Instead, we have to use logical steps to show that one side of the equation can be transformed to the other side of the equation. Sometimes we will work separately on each side, say maybe the left-hand side or the right-hand side. We work separately. Then we meet together in the middle in order for us to show that this identity is true. We follow systematic approach, a logical approach that will help us arrive at a certain answer. Now, what are those approaches that we need to follow? One, trigonometric identities are quantities involving trigonometric functions. You have to always remember that it is not just an identity, it involves trigonometric functions. And when we prove them, we try to ascertain that those functions are actually correct. Assuming that you are given a sine squared theta plus cos squared theta is equals to 1. How do we arrive at this conclusion that this sine square theta plus cosine square theta is equals to 1? That is what we are calling identities. We try to prove that this sign in our left hand side is equal to the side to one that we have in the right hand side, which is a function of that identity. So we are going to prove this, and at the end you will be able to follow the guidelines on how to prove those identities. Various trigonometric identities like the reciprocal trigonometric function and the Pythagorean identities should be familiar with us in order to prove these identities. Because in the reciprocal identities, there is always a format, and even in the Pythagorean identities, there is a format of which we are going to apply when we are trying to prove those identities. For instance, if somebody say, what is the derivative of sine in calculus? You are asked to find the derivative of sine. You know that the derivative of a sine is a cos, and the derivative of cosine is a negative sign. Those are the things that we need to know in our head as we try to prove these identities, because we are going to be applying them at one point or the other. These are the guidelines for proving identities. Work on the side that is more complicated and simplify it. You will be given two sides, the left-hand side and the right-hand side. So you have to work from the side that is more complicated and arrive at that other side, which is a bit easier to follow. Replace all trigonometric functions with just sine theta and cos theta where possible. Identify algebraic operations like factoring, expanding the bracket, or you can even use distributive property, adding and multiplying fractions. Of course, all these allow us to simplify the expression further and then prove the identity. Use the various trigonometric identities in particular. Then you watch out for the Pythagorean identity. Work from both sides. Keep an eye on the other side and work towards it. And finally, you consider the trigonometric conjugate. So let us jump into it and see some examples. Assuming that you are asked to prove that in bracket 1 minus sine x multiplied by 1 plus cosecant x is equals to cos x cot x. Of course, this is our left hand side and this is our right hand side. If you look at both sides, you will see which side is more complicated. Of course, cos x cot x is a bit easier. So we can take this side, this left hand side that is a bit complicated, and try to prove that this left hand side is equal to the right hand side. And how do we do that? When we take the left hand side, we know that we have 1 minus sine x multiplied by 1 plus cosecant x. Now we have 1 and we have 1, and we have sine and we have cosecant. So we can take cosecant and transform it into sine. We know from the identity that cosecant x is equal to, can be represented as 1 divided by sine x. So that is what I have done here. We have 1 minus sine x into 1 plus 1 divided by sine x. Cosecant x is simply represented by 1 divided by sine x. Of course, from here we can expand this bracket. If we expand the bracket, we will simply have 1 plus 1 minus 1 divided by sine x minus sine x minus 1 is equals to 1 divided by sine x minus sine x. This is multiplication. We have common, we have 1 here, and we know that 1, this by this will give us 1 divided by sine x. We still have minus sine x. Then minus this one, because we are distributing the signs, so that we have this will be equals to 1 divided by sine x minus sine x. Of course, if we go further, we will have 1 minus sine squared x divided by sine x is equals to cos squared x minus divided by sine squared x. There is an identity that represents 1 minus sine squared x. 1 minus sine squared x can be represented as cos squared x, and this will be divided by sine squared x. This identity can be represented in this format, so that we can now factor out cos x. Since we have cos squared x, if we will just need to factor out cos. So that is how we got cos x into cos x divided by sine x. Of course, we know that cos x divided by sine x is cot x. So we finally have cos x cot x. So we have proved that this identity 1 minus sine x into 1 plus cosecant x is equals to cos x cot x, which is what we have here. And that is how we prove trigonometric identity. Let us consider the second example. Assuming that you are given 1 minus 2 cos squared theta divided by sine theta cos theta, and this is equals to tan theta minus cot theta. Now, when you look at both of them, which side is a bit complicated? We know that we have sine and cos. Sine and cos are always easy to deal with, but here having tan theta and cot theta, it seems to be a bit complicated. So we are going to take the right hand side and prove that it is equal to the left hand side. So if we take tan theta, what is tan theta? Tan theta can be represented as sine theta divided by cos theta. And what is cot theta? Cot theta can be represented as cos theta divided by sine theta. If we bring them together, we will simply have sine theta divided by cos theta minus, because of this negative sign, minus cos theta divided by sine theta. Of course, this will give us sine squared theta minus cos squared theta into the common LCM. Here we have cos theta sine theta. And then we can try to do a bit of simplification so that we will have 1 minus cos squared theta minus cos squared theta into cos theta sin theta, because we are still dealing with our LCM. We have just simplified the denominator, and this is what we get. And if we go ahead, we will have 1 minus 2 cos 2 theta, that is cos squared theta, into cos theta sin theta, which can be represented as 1 minus 2 cos squared theta into sin theta cos theta. So we have proved that tan theta minus cot theta is equals to 1 minus 2 cos squared theta divided by sin theta cos theta. And this is how we prove trigonometric identity. Let us still consider the third example. You are given to prove that cot theta divided by cosecant theta is equals to cos theta. We start from the left-hand side, which is more complicated. Of course, this is our left-hand side. Cot. Whenever you see cos and sine, they are a bit easier. Look for things like tan theta, cot theta, cosecant theta, secant theta. Those ones are more complicated, and we always tend to start proving from that side. So when you see cot theta divided by cosecant theta, you already know that you are to prove from this side, because you will not be given the side to prove. You have to use your sense to know that when I'm giving these two signs, I have to prove from my left or I have to prove from my right. So in this case, we are going to prove from our left-hand side, cot theta divided by cosecant theta. So we just replace cot theta with cos theta into sin theta, because cot theta is equals to cos theta divided by sin theta, and cosecant theta is equals to 1 over sin theta. Now we can bring them together. We will simply have cos theta divided by sin theta. All this divided by 1 minus sin theta, which is cosecant theta. Remember, we are having cot theta divided by cosecant theta. So that is why this cos theta divided by sin theta represent cot theta, and is divided by 1 minus divided by sin theta, which is representing cosecant theta. Of course, we can do a bit of simplification. We will simply have cos theta divided by 1, because this here simply means we have cos theta divided by 1. Of course, cos theta from the right-hand side is already proved, because we know that this is equals to cos theta. The whole of what we have here is cos theta divided by 1 is an identity, and this can be represented as cos theta. Proved. It has proved that cot theta divided by cosecant theta is equals to cos theta. Let us consider the final example in this video. We are asked to prove that cos cubed theta, cos cubed x plus sin cubed x divided by cos x plus sin x plus cos cubed x minus sin cubed x divided by cos x minus sin x is equals to 2. So you are to prove that all this here is equal to 2. So what can we do? How can we start to handle this problem? We already know that a cubed minus b cubed is equals to a plus b. We know this from the Pythagorean theorem. We know if we are talking about a squared plus b squared is equals to c squared. But in this case, we have a cubed minus b cubed. This can be represented as a plus b into a squared plus b squared minus ab. So we simply need to replace whatever we have here using this identity. So we can actually apply it to prove these identities. Let us proceed and see what will happen. Now we know we have a plus b. It is simply as cos x plus sin x. This will be given by cos squared x. We have a squared, so it's cos squared x plus sin squared x. Now minus ab is minus sin x cos x. All this will be divided by cos x plus sin x that we have in the denominator, plus cos x, whatever we have in denominator here, because they are actually the same, except the sign here we have negative sin x. So we have cos x sin x into cos squared x plus sin squared x minus sin x cos x all this divided by cos x minus sin x. Now, if we do a bit of simplification, we will have 2 sin x plus cos x plus sin x cos x minus sin x cos x. We know that 1 plus 1 minus 1 is simply 1. So it is like saying sin x cos x minus this is plus sin x cos x minus sin x cos x. This is 0. So this is gone, and we simply have 2 into this. So you see that the whole of this is gone. We are left with 2. So we will have all this will be equals to 2, and we have proved from what we were given that this identity is equals to 2, and that is how we prove a trigonometric identity, and we arrive at our final answer. It is just a matter of following the concept. I hope you have enjoyed this video. Sometimes you might need to consult your advanced mathematical table in case you got lost. You don't need to cram this, you just need to know the format, you need to know the concept and the patterns in which you will follow in order to arrive at the final answer. Follow that guidelines, try as much as you can to work from the complicated side to transform these identities into what you want, and then you are good to go. Otherwise, this is the end of this video, and I hope you have enjoyed. Don't forget to subscribe so that you will be notified in our subsequent videos, as I will be taking you through on other form of trigonometric identities. Have a blessed day.